Hello everybody, I'm Abasud and welcome to my course on IoT devices, cybersecurity and risk management. In today's session, we are discussing about what is the difference between in an IoT and IT. IoT means Internet of Things, IT means information technology. So here we have divided it into three broader pillar. So let's discuss about one by one, then we'll go it in detail. So first one where we says first consideration what we are having is device interaction with physical world. So in case of IoT devices, interaction with the physical world is much more than as compared to the conventional IT devices usually do. The interaction with the physical world that IoT devices enable may affect cybersecurity and privacy risks in several different ways. Here we have example is IoT sensor data. Representing measurement for physical world always has uncertainty associated with it. Effective management of IoT sensor data, including understanding uncertainties, is necessary to assess data qualities and meaning so the organization can make decision regarding the data use and avoid introducing new risk. Without this, error rate may be unknown for the different contexts in which an IoT devices might be used. So next example is IoT devices with actuator has the ability to make changes to the physical system and thus affect the physical world. The potential impact of this needs to be explicitly recognized and addressed from a cybersecurity and privacy perspective. In worst case scenario, a compromise could allow an attacker to use IoT devices to endanger human safety, damage or destroy equipment and facility, or cause major operational disruptions. Privacy concerns and related civil liberties concerns could arise through authorized changes to physical system that could impact individuals physically autonomy or behavior in personal and public spaces. For example, physical access control such as automated door door locks could be used to limit access to rooms or building with individual inside, or environmental control such as lighting or temperature could be used to influence individual movement in buildings. IoT network interface often enable remote access to physical system that previously could only be accessed locally. Manufacturing, vendors, and other third party may be able to use the remote access to the IoT devices for management, monitoring, maintenance, and troubleshooting purpose. This may put the physical system accessible through the IoT devices a much greater risk of compromise. Further, these decentralized data processing functions can accelerate some privacy risks, making it harder for the individual to understand how the IoT device is operating so that they can make informed decisions regarding the processing of their information and their interaction with the IoT system. The next consideration, what we are saying is many IoT devices cannot be assessed, managed, and monitored in a way conventional IT devices can. What do you mean by that? Conventional IoT devices usually provide unauthorized people, process, and device with hardware and software access management and monitoring features. In other words, and framework, operating system, and application fully manage the devices and its software throughout the device life cycle as needed and monitor the internal characteristic and state of devices at all the time. Authorized user can also access a restricted subset of access management. In contrast, many IoT devices are opaque, often referred as black box. They provide small or no visibility into the state and composition, including the identity of external services and system that they interact with, and little or no access or management of their software and configuration. The organization may not know what capabilities an IoT devices can provide or is currently providing. In extreme cases, it may be difficult to determine if a black box product is actually an IoT device because of the lack of transparency. So, if we are talking about the cybersecurity and privacy risk, so there are multiple factors. One is we can say the lack of management features. So here we can say administrator may not be able to fully manage an IoT device firmware, operating system, application throughout the IoT device lifecycle. Unavailable feature may include the ability to acquire, verify the integrity of, install, configure, store, retrieve, execute, terminate, remove, replace, update, and patch software. In addition, IoT device software may be automatically reconfigured when an adverse event occurs, such as power failure or loss of network connectivity. Second is lack of interface. Some of the IoT devices lack of application or human user interface for the devices use and management. When such interface do exist, they may not provide the functionality usually offered by conventional IT devices. For example, challenge in meaning challenging notifying user about the IoT devices processing of their PII so that they can provide meaningful consent to their processing. An additional issue is the lack of universal accepted standard for the IoT application interfaces, including expressing and formatting data, issuing commands, and otherwise fostering interoperability between IoT devices. Next is difficulties with management of scale. Most of IoT devices does not support standardized mechanisms for centralized management, and sheer number of IoT devices to be managed may be overwhelming. Next is wide variety of software to manage. There are extensive variety of software managed by the IoT devices, including firmware, standard, real-time operating system, and the applications. This significant complicate the software management throughout the IoT device lifecycle effect, such as area of configuration and patch management. Next is differing lifespan expectation. A manufacturer may intend for a particular IoT devices to only be used for a few years and then discard. An organization purchasing their device might want to use it for a longer time, but the manufacturer may have stopped supporting the device, means they have stopped releasing the patches for the known vulnerabilities, either by choice or because of supply chain limitations. Supplier no longer release the patches for a particular IoT device component. The problem of differing the lifespan expectation is now new and and is not specific to IoT, but it may be particularly important for some of the IoT devices. Next is unserviceable hardware. IoT device hardware may not be serviceable, meaning it cannot be repaired, customized, and inspected internally. Next is lack of inventory capabilities. IoT devices bought into an organization may not be inventorized, registered, or otherwise provisioned via normal IT processing. That this is especially true for types of devices that did not previously have networking capabilities. Last is heterogeneous ownership. There are often heterogeneous ownership of IoT devices. For example, an IoT device may transfer data to a manufacturer provided cloud-based service processing and storage. Data may also sent to the cloud service to aggregate data from multiple IoT devices in a single location. These cloud services may have access to the portion of or all of the device data, and even access to and control to the device themselves for monitoring, maintaining, troubleshooting purpose. In some cases, only manufacturer has the authority to do maintenance, and organization attempt to install patches or do other maintenance. Now, our third and last consideration is availability, efficiency, and effectiveness of a cybersecurity and privacy capabilities are often different for in IoT devices than IT. What it mean? It says many IoT devices does not or cannot support the range of cybersecurity or privacy capabilities typically built into the conventional IT. For example, black box IoT devices may not log its cybersecurity and privacy event or may not give organization access to its log. If pre-market capabilities are available for IoT devices, they may be inadequate in terms of strength of communication or may cause unacceptable delay. Post-market capability cannot be installed onto many of the IoTs. Also, existing pre-market or post-market capabilities may not be able to scale to meet the need of IoT. For example, an existing network-based cybersecurity appliance for conventional IT devices may not be able to also process the volume of network traffic and generate data from larger number of IoT devices. Next can be the level of effort needed to manage, monitor, and maintain the pre-market capability on each IoT device may be excessive, especially when IoT devices does not support centralized management. It may be more efficient to implement and use centralized post-market capabilities that help protect numerous IoT devices instead of trying to achieve the equivalent type of protection on each individual IoT devices. One example is having a single network-based IoT protection on each individual IoT devices, IoT gateways or IoT security gateways, protecting many IoT devices instead of having to design, manage, and maintain the unique set of protection capabilities within each IoT devices. Some post-marking capabilities for conventional IT such as network-based intrusion prevention system, anti-malware server, fireware may not be effective at protecting at the IoT devices as they are protecting the conventional IT. IoT devices often use protocol that cybersecurity and privacy controls for conventional IT cannot be understand and analyze. Also, IoT devices may communicate directly to each other, such as point-to-point wireless connection instead of using monitored infrastructure network. So this is what we are having today as a difference between IoT and IT. Thank you for joining.